Welcome back to the Open Infra Summit in beautiful Berlin. Let's give another warm welcome to Allison Price and Jonathan Price.
Good morning again, everyone. Allison, who decided to have Jimmy do the intro recording?
Not at me.
Yes, that voice talent is Jimmy MacArthur, who works at the foundation for now. Hope everybody had a great first day. I really had an awesome time yesterday. Had so many great conversations, got to reconnect with a lot of people, talk about all kinds of interesting topics. Really enjoyed it, and then probably stayed up too late and drank too many beers and glasses of wine, but
we're here.
That's what the summit's about. So yes, welcome back to day 2. We just have a couple of quick housekeeping reminders, and then we're going to get into our content today, where we're going to cover science and hardware and safe hardware and all kinds of great topics.
5G, yeah.
5G. So just before we get into that, first we got a couple of housekeeping items to cover. So
yeah, if you haven't already, and I can see a few out here, pick up your T-shirt sponsored by Mirantis. It's available during the midday mixer this afternoon. So just take your ticket from your badge, and you should be able to get that this afternoon.
And as a reminder, we are doing our fundraiser for Ukraine. You can follow the bit.ly link up there, which I know is a little long, but there's a QR code if you want to scan that and contribute to World Central Kitchen, which is helping to feed people who are displaced and kind of prevent food insecurity for people who are going through a tough time right now.
Yeah, and a huge thanks to everyone who's already donated. We had several come in yesterday, so thank you. We'll be matching that at the end of the week. And as a reminder, when you're visiting sessions here in the keynote, please continue to wear your mask throughout the venue. We want to make sure our community stays safe throughout this week and when they return home, so please continue to wear that throughout the summit this week.
And finally, we always do surveys at our summits. We love to get feedback, so please let us know how we're doing. There's another link here. It's bit.ly/Berlin Summit 2022 survey, actually just 22 survey. The things that we like to hear about are, how do you like the venue, the city, the food, the sessions, all of that is in there. Now that we are starting to get back into our event cycle, we definitely want to know what people are thinking, and we'll incorporate that in the future. I've heard, for instance, that some of the sessions were a little bit overpacked, and we ran out of capacity. We've rescheduled some of those too, so if you tried to get into something yesterday and couldn't, check the schedule again, and we are doing a round 2 on some of those so that everybody can get into those. So that's it for the housekeeping. We're going to go ahead and get the content started. So please help us welcome the GM of the Open Infra Foundation, Thierry Carrez.
Hello, everyone. Welcome back for day 2 of the Open Infra Summit in Berlin. I hope you had a great day yesterday. I've had the chance of walking the halls and attending a few sessions, and it really feels like it felt like a lot of engagement and a lot of energy in the rooms, and a lot of familiar faces as well. And so it's always great to see that the community is coming back together. We were clearly missing this. A lot of hallway track discussions, a lot of small groups talking about very important topics all together. It was really great to see. And I still see a lot of familiar faces in this room today, but I know that more than half of you are actually here for the first time at an Open Infra Summit. So for those who don't know me, I've been in this community for a long time. I joined OpenStack back in 2010. This is a younger version of me for our first summit in Asia. And that was the OpenStack Technical Committee at the time. And yesterday, someone asked me, when I mentioned that I've been doing this for 12 years, someone asked me what I was actually the proudest of. Like, what is the achievement that we managed to achieve collectively that I'm the proudest of? And it took me a while to think about it, because clearly a lot of things happened over the past 12 years that I certainly did not anticipate starting this journey. And so it could have been, the fact that we managed to reach a level of activity within an open source project that was unmatched. Only a very few number of projects have reached that level of 100,000 changes per year. It could have been closer to my involvement as a release manager for OpenStack, like the incredible continuous integration, continuous delivery release management system that we built to support the development of OpenStack and reliably release on time 25 releases so far. Or it could be just that I'm still around here and talking to you today, witnessing the end of the OpenStack release alphabet. It's all, to me, secondary to what I'm the proudest of thinking about it is really you, this community that we assembled. And this is like individuals and organizations that are motivated by this idea that you should be using open source software for providing infrastructure. Beyond the software, it's really what we created as a group. And back in 2010, if you think about it, providing infrastructure was really the realm of proprietary software. So this community is a new thing that we assembled, people that care about using open source for providing infrastructure for others to build solutions on. It's a community of developers, of operators, an ecosystem of companies that are interested in building businesses around those objectives. And it's really great to see what's been happening. We've been managing over the past 12 years to assemble a group of more than 100,000 community members in 187 countries around the world, involving more than 450 organizations. And for some of those organizations, it was actually their first contribution to open source. So we brought new organizations, sometimes very large tech companies that you all know the names of, into contributing for the first time to an open source project. So that's really a great achievement. And because of you, because of what you have accomplished as a community and how you have guided us, we're now the Open Infra Foundation. And how have we grown such a large community? Well, this is another blast from the past, a younger version of Jonathan Bryce in 2013. And in 2013, he actually aged well as well, In order to, back then in 2013, Jonathan introduced this concept of the three forces. It's this idea that for an open source project to be successful, you have to balance three forces: the developers who write the code, the users that are installing the code, and an ecosystem of organizations that are building businesses around it. And back then, when that was introduced, I was actually very focused on the developers force. It was my only scope. I was working on developing the strongest group of developers that we could attract to the project. And I was naive back then. I was thinking that, good code is enough. If you write the perfect code, users will come and companies will form and everything will be happy. But I was mistaken. Luckily, others at the foundation were working on developing those other forces, the users and the ecosystem, like Tom Fifield working on strengthening our users group, or Lauren Sell working on developing a very massive ecosystem of companies working on this. So OpenStack taught me really how important it was, because it's very important to balance those three forces. Without an ecosystem of companies, you don't really have the resources to fund developers to work on that code. Without developers, you don't really have code to talk about. And without users, well, what's the point? Like, we are saying that we are building communities that write software that runs in production. And all the words in that sentence are important. If you don't have code being written, what's the point? If you don't have users using it in production, what's the point? So it's very important to sustainably develop a community that you develop and balance those three forces. And looking at OpenStack, this is what we achieved. Like, we managed to develop the ecosystem force up to more than 400 different organizations being involved in OpenStack. We managed to collectively add up to more than 8,000 developers contributing code to OpenStack. And from the user perspective, this code runs on more than 25 million CPU cores around the world. And actually discovered more yesterday, so that number is going up. But in practice, how does this work? How do you develop and balance those three forces to build a sustainable open source community? So if we zoom in into the developer force, this is the type of work that we are doing today to help with developing that angle. For example, we are producing a separate event from this event called the Project Teams Gathering. And it's a very specific format. This idea is, the idea behind it is that you should have developers, the people that work together around the world all year long, should have a place to get together for very intensive work sessions that is separate from this summit environment that is very busy and very difficult to do any focused work on. So we built this separate event where all those teams can get together, discuss what they should be focusing on, discussing what are their priorities, building trust between team members, reaching alignment on important decisions, solving hard problems. And this is happening in a venue where multiple of those groups are working together. So you are seeing a lot of cross-pollination happening between those groups working on open infrastructure in general. And it's really great to see. I'm very happy that we'll be able to do that back in person this year in Columbus, Ohio in October. But we also worked on onboarding and mentoring. That's really an important thing because you need to have the constant influx of new developers. You need to be a welcoming community. You need to onboard those developers to the systems that you built to support the development of those projects. You can also sustain very essential project functions like release management or vulnerability management or sustaining the infrastructure that is necessary for the developers to work on. Those are all the things that we are doing today to support the developer force. Looking at the user force, we have a specific format as well that is happening in level A of this building, the basement floor, where you will see that there is a forum rooms. These forum sessions are different from your usual presentations, and you might have stumbled on some of them yesterday. They have arranged the seats in a very peculiar manner where people are facing each other. And the goal is to have this community, or at least a cross-section of this community, users, developers, but also companies, contributing to discussing specific problem space within our projects. And having like a live discussion where they confront their views and feed back into this feedback loop back to the developers so that that influences the next features or the next work that is being done. We're doing the large-scale SIG, which is an effort to get operators of the largest deployments of OpenStack that have been through this journey of scaling up their deployments to a massive amount of a massive footprint, to share their experience with people that are more at the beginning of this journey. Like, what did they learn? How did they solve problems? What are the type of problems that they encounter? And it's really key to get those people to share their experience for the newcomers to have a more peaceful journey scaling up their deployments. We are featuring users in Summit keynotes. We're supporting community events either financially or having keynote speakers speak to those events to spread the words around those projects. And that builds up this user force a lot. Looking at the ecosystem force now, we do a lot of it's important for those businesses to rely on a strong brand, and so just making sure that someone calls their product OpenStack is actually OpenStack. So that's the work of the brand building, that's the work of the trademark programs, making sure that, like, if you say you're including OpenStack in your product, it's actually running OpenStack. We're also having a Summit marketplace, level B of this building. You'll see all those booths. This is where all the ecosystem companies can showcase their products around open infrastructure, and I invite you to visit them. And there is also the reflection of that called the online marketplace on openstack.org, where all of those companies can also get featured and their products being showcased there. So this is what we are doing today. What we are doing today is packaging up those services into a reusable package that can be applied to support the next decade of open infrastructure projects. And those services are all important, but they can't really happen without resources or funding. So how do we get resources for those services? How do we apply this model in a sustainable manner? Well, the way to sustainably fund those services is really, and achieve all of those results that I talked about, is really to pool resources across multiple organizations and allocate efficiently based on the needs of the project. And so in order to host this next decade of open infrastructure projects, today we are combining this model that I just talked about, developing and balancing those three forces with a funding model where we ensure that we can transparently pool resources across multiple organizations and allocate the resources to the things that the projects need the most. And you can learn more about this project model, this project hosting model, on the website, on the OpenInfra.dev website. You can visit this URL if you want to learn more. We're basically now open to build the next decade of open infrastructure. And if you have a project around open infrastructure, if you want to build an open collaboration around it, well, talk to us. We're open. Thank you.
Thank you, Thierry. It's a little hard to hear back there, but I understand that he made some aging joke. I'll have to plot my revenge later. Thierry talked about kind of the model for how we support projects and host projects. Yesterday, Mark talked about kind of the opportunity in the market overall. And one of the things that we do to kind of bring those things together for a lot of our projects is make sure that users and potential customers are able to find commercial offerings in the market. And we actually just launched a new section within the OpenStack marketplace for infrastructure solutions and consulting. This is something that we actually had been getting a lot of inbound interest to the foundation. Sometimes they were asking us to help them. That's not really what we do on kind of a case-by-case basis. This is why we like to have a strong commercial ecosystem. So we have now rolled out a new section of the marketplace so that if you need help deploying open source infrastructure software, you can go there and you can find consultants and people who will help you with that in different regions all around the world. So it's a great new section and a good resource for folks out there.
Yeah, and another thing that Thierry covered was the importance of getting new contributors contributing upstream. So whether it's here at the summit or once you go home, there's lots of opportunities to get engaged in different open source communities. So next, we're actually going to have a talk from someone who is very new to the community, who just finished an outreachy internship, as well as someone who's been a veteran through the OpenStack community, the Cinder team, to talk about the different ways that you can get onboarded into an open source community that you would like to participate in. So please join us in welcoming Kendall Nelson and Archana Kumari.
Hello, everybody. Thank you for being here today, and we hope that you enjoy the rest of the week at the summit. Onboarding isn't just a single program for everyone. There are a number of types of onboarding for very different audiences. Everyone from new member companies to the individual contributor starting on one of our projects can benefit from onboarding programs. The variety of programs we offer are supported not just by the foundation, but the individual communities under the foundation. And education about open source and the Open Infra way needs to happen at all the levels to be effective. So the first program I want to talk about today is one that OpenStack and the foundation have been involved with for a very long time, and that's the Outreachy program that's hosted by the Software Freedom Conservancy. This program is what actually brought us Archana, who is here to talk about it today.
Thanks, Kendall. So Outreach is a 3-month-long open source program which supports diversity initiatives by providing paid and remote internship. It runs twice a year. During the 3 months, applicants get paired up with some amazing mentors to work on open source project tasks and get a chance to build a lifelong connection with so many people around there. So I came to know about OpenStack through Twitter when Victoria, she is my mentor, tweeted showed up in my feed that they are looking for Outreachy intern for a OpenStack Manila task. I showed my interest to her, get some clear details about the task. Also, when I got to know that their whole open source environment and the open source environment is very different. Also, when I got to know that it's just not GitHub, I found it so exciting and challenging because I was totally new in the OpenStack world and prepared myself to become an OpenStacker, or as Zorilla, I can say, this is what we see to Manila contributors. The most I like about the program is the confidence it gave to me, and this happened because of my mentor, Victoria, Gautam, Carlos, and Mari, and the people I met in the community, Kendall, Allison, and Helena. During those 3 months, every day there was something new to figure out, something new to work on. So I solved those issues that actually gave me confidence. So whenever I reach out to my mentors, whenever some issues I hit, they didn't just provide me the solutions, but the way how I can figure out the inner general. So I still apply those points in my life and in work. Also, the community here and the people are so welcoming. From sending my first patch on Garrett to here I am speaking as a keynote speaker, and yesterday I was standing with my mentor to deliver a forum session. Nothing was easy, but it's all happening and happened because of the people I met during my internship, and they actually made me stay in open source and into this community. I got a belief in me with that. Outreachy, OpenStack, and the whole Open Infra community gave me a confidence of figuring out attitude, and I choose to stick with it. Also, I want to say there are so many opportunities out there in the open source world. Even if it's not, you just need to show your interest, and you're going to build it by yourself.
Programs like Outreachy are crucial to the health of the Open Infra community and the larger world of open source because they help build diversity while bringing new contributors into our communities. Over the last couple of years, I've actually built relationships with a number of universities up here. And I match these students in different courses with mentors in both OpenStack and more recently Kata containers to educate them about open source, working in global communities, while getting them hands-on experience coding and reviewing code. And after that, they can take this and put it on their resumes when they graduate from university. So it's a win-win situation. If you know of a university professor or a course that's looking for opportunities like this, please reach out to me. This is one of my favorite parts of my job, and I would love to connect your university with our projects. I also want to give a quick special thank you to all the community members I've worked with on these programs. You are some of the most invaluable contributors to our community, and your mentorship is greatly appreciated. In partnership with Telecom Paris, I've been working on a higher level MOOC to give people the basics of working in an open source community as a stepping stone to getting involved with projects like those we host at the Open Infra Foundation. So this MOOC basically walks students through how to find an open source project, the importance of communication, and how to dig into that community and get started. So if you don't have experience working with open source, this is a good stepping stone place to get started before you dive in. Onboarding is not always repositories and reading contributor guides, though. we also work with adjacent projects, organizations, and events to spread the word about our communities. For example, the OpenStack community has attended the Open Source Day during the Grace Hopper Conference for several years now. And I've participated both in person and virtually, obviously, for the last couple of years. Archana will talk a little bit more about the virtual event last year that she was able to help us with as well.
Yeah. So during the internship, I came to know that Grace Hopper Conference Open Source Day, which is a different open source program to help beginners to make their first contribution in the open source world, to do something similar to what my mentor does, which is helping people to make their first contribution. I followed her footprint and mentored some folks there with the help of active mentors. To make things clear, for the first time contributors, we kicked off the session by delivering some, like, what is OpenStack, how you can contribute and communicate here, what is Git and Garrett. Also, Kendall was there too, who showed them a demo from like picking bugs on the launchpad to sending patches on the Garrett. This is how I started doing open source mentorship for the first time, and that was a great feeling indeed. I want to say big thanks to my mentors for helping me to grow so much, and this community to like letting me do the same for others. Thank you.
So we were recently contacted by the Grace Hopper Conference organizers, and I've actually signed up OpenStack again for the Open Source Day later this year, but I'm really hoping to get our other Open Infra projects involved to continue to spread the Open Infra way through new avenues. So if you are involved in one of our other projects and interested in mentoring, reach out to me, and I would love to get you involved there. So as for this week specifically, there are a number of sessions yet to be held that are focused on bringing people into the projects that are going on today and tomorrow. If you're passionate about open source and want to get involved, these would be great opportunities to do so. The forum is really the place to go for the next 2 days for getting involved with teams. CloudKitty, Blazor, Diversity and Inclusion Working Group, and Nova and the Scientific SIG all have sessions today. And tomorrow, there'll be even more focused on the bare metal SIG and the future of the public cloud. I realize, though, that not everyone can be involved here this week, so if you can't participate, go out and seek those contributor guides. All of our communities have some sort of new contributor guide, whether it's a slide deck or a README file or anything in between. We've got it all. You can get involved, and there will be people to help you if you're willing to take the leap into the Open Infra way. Come join us. We are Open Infra.
All right, so now we've talked about how to get started as a contributor, contributing upstream in the communities. But like Thierry said, once you start building code, one of the biggest things you want to see is how is it actually used in production. So today we have a few different use cases across some different industries that we're going to be highlighting. So first we have a segment on scientific research. So please join me in welcoming from BBC R&D, Stuart Grace.
Good morning. BBC Research and Development employs around 200 people to explore and develop innovative technologies to transform the BBC and the wider media industry. We work across many areas, including journalism and news gathering, radio and television production, distribution and archiving, web content and media streaming, data science, and new audience apps and experiences. Within R&D, we've built a few private clouds for our own use, using OpenStack, backed by Ceph, deployed with Ansible, and monitored by Prometheus. These allow us to explore and prototype specialized media processing functions in the cloud that the BBC could use in the future, but they also provide a general-purpose platform to support various other projects within the department. The workloads running on these OpenStack platforms are very varied and include video and audio production and storage, AI and machine learning applications, and general software development and deployment. Like many other organizations, the BBC is aiming to reach net zero carbon emissions by 2030. Our users in R&D want to contribute towards this goal by being as efficient as possible with the energy used by their own work. Now, the conventional way to estimate the emissions from software workloads is top-down. You take the energy consumption for the whole building, work out the part that goes into the data center, and then divide that down between the various servers and so on. This gives a complete value, including all the overheads such as lighting and cooling. But these overheads are largely fixed and completely beyond the control of our users. There are also the embodied emissions that were created when all the hardware was manufactured and shipped to site. But again, this is outside the control of our users. We wanted to give our users data about the things they could actually control themselves. So we started bottom up, inside the CPU. Intel and AMD CPUs include registers in the silicon tracking the running average power limit. That is, the amount of energy consumed by the CPU chip each millisecond. And of course, the Linux kernel will tell you the amount of time each processor has been using the CPU. Hublot have created an open source monitoring agent called Scafandra, which uses these data sources to calculate the amount of energy which has been consumed by each process running on the bare metal. So we installed Scafandra on all our compute servers, and using its built-in Prometheus exporter, we collect all the data centrally in our Prometheus time series database. But that works in terms of process IDs. So we also query the OpenStack API to find the instance metadata, and then we can match up these process IDs with instance name and the owning project. This tells us the kilowatt hours consumed by each virtual machine. But kilowatt hours are not all the same. A kilowatt hour generated by a wind turbine is essentially carbon-free, but one generated by burning fossil fuels releases hundreds of grams of carbon dioxide. But we can account for that because in the UK, all electricity is transferred from all the generators to all the consumers by the National Grid Electricity System Operator. And they have an open API which gives you historic, current, and forecast future data about the mix of fuel sources being used to generate the electricity in each region of Britain. They also calculate and publish the carbon intensity. That is the grams of carbon dioxide released for each kilowatt hour of power generated, region by region and hour by hour. So we poll this API as well and combine all this data together in Prometheus to calculate the power consumed by each virtual machine and the carbon emissions, taking into account when and where that power was generated. Finally, my colleague Sonal Tandon created various dashboards in Grafana to present all this information to our end users. So if we look at some examples, this is a project summary dashboard for one particular project over a selectable time period, in this case 4 days. And you can see the virtual machines in this project used about 10 kilowatt hours of electricity during that time. And that resulted in the emissions of 1.4 kilograms of carbon dioxide. And to make that more understandable, we say that's equivalent to boiling a kettle of water 55 times during those 4 days. And remember, this is just the CPUs. It doesn't include the networking or the cooling or anything else. To show the importance of the carbon intensity, we also provide this view, which shows power consumption and carbon emissions side by side over the same time period. You can see in this example the two large spikes in the power consumption corresponding to surges in the workload being processed by this project. But on the other graph, you can see the first spike resulted in almost no carbon emissions, while the second spike produced a lot of carbon dioxide. And you can trace the reason for this back to the fuel mix data, which we also present. And you can see during the first spike, most of the electricity in London was being generated by wind turbines. But during the second spike, the wind had dropped, and it was mostly being created by burning gas. Well, that's all very interesting, but what can users actually do about it? Well, using this view, you can compare all your virtual machines side by side over the same time period. And this allows you to experiment with different software, different architectures, different flavors, to optimize your system to minimize its power consumption. You can also compare your VMs with similar VMs from other teams, so we can spread best practice between the teams. You may also be able to relocate the data processing to a different data center. Using this map view, you can see the carbon intensity for different regions. And as you can see, it can vary considerably. So shifting the data and processing it in a different data center could reduce the environmental impact. And finally, if the data is not time critical, then you can schedule it to run at a more environmentally friendly time. This graph shows a forecast of carbon intensity for London over the next 24 hours. And you can see for non-time critical workloads, scheduling those to run towards the end of that time will reduce the carbon footprint. So what else could we do with this? Well, we can add data for DRAMs and GPUs quite easily. Those metrics are already available. It's much harder when it comes to things like the network hardware. The power consumption of a switch is determined more by its maximum speed than by the data flowing through it. So how do we apportion that fairly between the different users that share it? And also the Ceph storage. How do we balance the volume of data being stored against the number of I/O transactions? It's not at all simple. Another interesting area would be to delve inside the VMs themselves. Using the latest versions of software, you can actually run a copy of Scaphandra inside each VM. And that will allow the users to explore the power consumption process by process. So as we make all the rest of the equipment in our data centers more and more efficient, a bigger proportion of the energy ends up going into the compute servers. And these tools let our users improve the efficiency of what's running inside those servers, and that can help us reduce our environmental impact. Thank you.
Thank you, Stuart. That was a really cool use case. When we first heard about that, we were like, we have got to get that on stage at our next summit. I think that it's just, to me, what's great about it is not just the kind of direct impact that they're having in tying together the usage of their systems to what's happening with our environment and their power consumption and everything, but also the way that they have pulled together this whole set of open source tools to make something that's just super powerful. So thank you for sharing that use case, Stuart. Next up, we're going to continue to stay in the realm of climate, and we have a really interesting speaker that is more on the climate tracking and monitoring and prediction side. So please help me welcome Dr. Vasileios Baousis to talk about the European weather. Thank you.
Good morning. Good morning to all, everybody. I'm going to talk about how to make an Earth system model and Earth observation data available through cloud computing. First of all, I would like to start with who we are, actually with what is ECMWF, stands for European Center for Medium Range Weather Forecast. We are an intergovernmental organization established in 1975. We have 35 member states, mainly from the European Union, and we have headquarters, as you can see, in Reading and Bonn, and also our data center is being moved to Bologna. In a nutshell, actually, what we do, we run the forecast model. Our forecast model is called IFS, Integrated Forecasting System, and actually is the most reliable and with the best predictability of all the existing global models. We are a research institute with 24/7 support. We run twice a day the main product that we disseminate to everywhere in the globe, and actually we archive all of the data that we produce and we assimilate in our big data base. So we have an HPC running the models. In general meteorology, we need to run these models in HPC. We have one of the biggest HPC in the world. We always listed every 5 years in the top 10 HPC centers in the world. We have also cloud infrastructure that we run some Copernicus services. One is Copernicus Atmospheric Monitoring Service and Climate Change Service, Copernicus Climate Service. And we also contribute to other Copernicus services. We also have the European Weather Cloud, which is actually the main topic of my presentation, where we're going to discuss about how we make available this data. Finally, something that we are proud is the climatological data. It's about 300 petabytes that are available to our member states, and they can be retrieved with APIs globally. So this is more or less the current status of our HPC. On the left-hand side is our current 2 clusters that are located in Reading, in the UK. And then next is the next phase that we're going to deploy that in Bologna. So, and having said that we have all this equipment, we need some ways to give access to data. HPC is nice and user-friendly for the users, but actually cloud computing is easier because you have direct access and you can do more than the HPC. So that's why we came up with the idea to create the European Weather Cloud, which is a collaboration between us and EUMETSAT. EUMETSAT is another European organization for the exploitation of meteorological satellites. And actually, because the meteorological community is a mature community that we've been working together for more than 40 years, we built this cloud community cloud. Yeah. So as I said, we started again, a few years ago. We expect to be operational, fully operational now, but also currently we have also something running, and we are proud about that and about the use cases that we have there. So the basic goal is not innovative a lot, but the main idea is to bring the computation closer to the data. But also the goal of the project was to make this available and federate with other cloud provided by other member states. So we had a few things to do to build the infrastructure, operating, and all the between the 2 organizations. And actually, as ICMWF, we decided to go open source. We deployed everything with open source software, OpenStack, Ceph. And we are very happy with that we did it this way, and we are very keen to always use and make available our code to the community. All the meteorological software that we developed, everything is open source. So this is more or less the production and the workflow of ICMWF. We have the acquisition, we run the model, and then we archive this model and we make it available either directly to the European Weather Cloud or through our data handling system. So there, the member states, either they can run their computation, they can do whatever they like in our cloud, and then either they provide that to their end users, so European citizens, etc., or they can use any cloud service provider as a front end and as a back end European Weather Cloud. So this is more or less how this is structured. So we have a page that we can, this is accessible from the member states. And then we have 2 cloud orchestrations located on 2 organizations, one at ICMWF and another one at EUMETSAT. But all of these orchestrators can create virtual resources to any other associated or federated cloud infrastructure. And this is more or less what we described here. So, and the user space in general, what we, first of all, we have all the member states from our, that are members of ICMWF and EUMETSAT, and we are trying also to expand to other domains, like for climate and weather, not only in this community, but also to Earth observation data and finance and GIS. So what we do is, as I said before, is that we bring the computation closer to the data. We make APIs, standard APIs to access our data from the cloud. And also, cloud and HPC are complementary resources that are available to end users. And actually, what we can see later is that the use cases that we are currently running at European Weather Cloud are very useful for the end users and actually the European, but not only European citizens, because the cloud is not geographically restricted. So here we can see the different activities and the themes that we have in our cloud now, from training, from data exploitation, mining, everything, and also operation system support. Recently, a few years ago, our member state, due to their earthquake, they had no infrastructure, so we helped them a lot to bring up the infrastructure, and during this crisis, they are happy to run everything on the European Weather Cloud. So we run training sessions. We have at ICMWF, we run also DWT, which is the meteorological service of Germany. They run the ICON lab there. We have other activities from Meteo France, the meteorological service from France. And we have also some other interesting activities with Southeast Mediterranean countries that they have an application for predicting hazards. And also DWQ, we have the geoportal running there and many other activities like the summer weather code where developers test their code within our infrastructure. So all these things is what we do. European Weather Cloud is, again, it's a community cloud that we share with our member state, but member state, when I say member state, is the Meteorological Service and all the research organization and companies, research institute in this country. We try to bring together this community out of this federation of clouds, and also we provide some building blocks that they can build their own applications and make their application easier to the end users. So what we're trying to do is to, in the future, is to go beyond infrastructure as a service, platform as a service, and software as a service, but also to federate with member states, other cloud providers, and also help on the Destination Earth, which is the next big flagship of program of Europe, where the digital twins of the Earth are going to be running for the extreme weather forecast and climate change. And then we also participate in the evolution of the cloud and edge computing as well with European projects. That was all. Thank you. And later on, more technical details in our session. Thank you. Thank you.
All right, so if you're interested in learning more about the technical details about what Dr. Baousis just covered, there is a session later today. But as a reminder, like Jonathan mentioned, we are shuffling some rooms. A huge shout out to Sarah from our production team. She has been working tirelessly to make sure we don't have some of those overcrowding issues. So please make sure you check the schedule. We're updating it throughout the day when we have some of these changes. So some of these rooms may be fluctuating throughout the week. All right, so we've covered a lot of scientific research this morning, but one of the folks I wanted to bring out next was someone who's really active in the community. You've definitely seen him at a few summits if you've been to one, and he's the co-chair of the scientific SIG, so please welcome Stig Telfer. All right, we're gonna get the slide fixed maybe. Anyways, so we just covered a lot of different scientific research, and so I know you're really passionate with the community, and like Mark talked about yesterday, the power of getting all of these organizations together is what really makes a lot of these things really work. So do you want to chime in on some of the things that we've heard about this morning?
Those presentations were just fantastic. I loved what the BBC are doing. I think that one of these days, all of our clouds, all of the work that we do is going to be measured in terms of the energy it consumes. So I'm really pleased to see not only that they've done the work, but also that they've shared it as well. So that's just fantastic. I can see myself, I've taken lots of notes. I'm going to be retracing their steps, and I think it's brilliant. And the ECMWF presentation as well, it's just the scale of their ambition is inspirational. And I think also it really shows about the sort of traction that OpenStack is getting in this among these institutions that are seeking to produce the next generation in high-performance computing infrastructure. So they're a great example. There are many others, but they're really leading the way there.
Awesome. Well, I don't think we can talk about scientific research without talking about COVID, right? So we've been through the pandemic for the last 2.5 years. So how is open source powering some of the scientific research against the pandemic and some of the different vaccines that have been developed?
Yeah, I think it's been a busy time. Yeah. So. One thing that I've seen is that it's sort of introduced this term of urgent computing. And that's this idea of, well, how do you drop everything and repurpose everything you're doing around some new critical demand, like COVID? I saw a fantastic presentation by a group in the UK, the Cloud Infrastructure for Microbial Bioinformatics. And they were telling me they did this presentation about how when COVID first erupted across the UK and Europe, they had a week to create a national data bank for the COVID genome sequences. They did that, and they got their first sequence uploaded within 6 days. And being able to do that on an OpenStack system is really it's just a great example of, it's testament to how the agility of open infrastructure can really work in these situations, not to detract anything from the heroic efforts of a really brilliant team as well. So I think that the way that COVID has affected open infrastructure or in the scientific space has been really, it's been quite dramatic, really. I mean, it's been an intense period, I think.
Yeah, I mean, I can't even imagine. I mean, a week to get all of that going and to save lives has to be very, having OpenStack being able to do that is really.
Now I think they have 3 million sequences out of a global total of 7 million. And this infrastructure in the UK has been processing 3 million of those. And I think there's plenty of other stories around the world of the similar kind of thing where open infrastructure and OpenStack sites have been working at the forefront of this, the reaction to the COVID pandemic.
So you mentioned like all this research happening around the world. So you can't talk about all of this in the open source community without bringing up the scientific SIG, which is really hard to say because you're Stig. But you have a lot going on this week, and just like overall with the community. So what are you looking for in terms of collaboration, and how can people actually get involved?
Well, the SIG is so it's mostly a bit of social infrastructure, really. I mean, it's just about getting people together, sharing and sharing your problems and your solutions, and just sort of talking things over. So it's really very much a social mechanism. In some sort of meat and potatoes terms, really, we get together in a forum session. There's going to be one later this afternoon, and we have lightning talks, and people present what they've been doing, if there's anything interesting going on. If we're lucky, we'll go out for a dinner afterwards, when the business of the day is done. In between those times, in between the summits, there's a Slack channel with about 150 people in it, which is fairly active. We have had IRC meetings, but COVID and lockdown has really made those quite difficult, partly because a lot of people are very busy, and also because it's just hard when you can't meet people and everyone's working in lockdown, just to find new material and hear about the stuff that other people are up to. So I'm really looking forward today to this session later on to reconnect with a lot of people and start to reinvigorate some of those discussions and really learn about what we're going to be doing, what's happening in the open infrastructure world for scientific computing.
Absolutely, and like you said, there is a SIG meeting today, we're actually right after keynotes, so make sure you go hang out with Stig and learn more about how you can get involved. And there's also some more production use cases about how open infrastructure is being used around the world for research, scientific research and computing. So we've talked a lot about scientific research and HPC workloads this morning, so the next segment we're going to be talking about is also connecting people around the world, and it's going to be around 5G. So please join us in welcoming George and Mohammed.
See you later.
Didn't even try.
Hello, everyone. Such a pleasure to be here.
Thank you.
This is my first in-person experience here at this summit, so I'm excited to be here. I'm excited to talk about the 5G ecosystem in Canada with you. At Sienna, we're global leaders at providing advanced networking systems and solutions for the telecom industry. And we also have a strong R&D presence in Canada. And through our presence there, we're able to take part in a program called Encore. So what is Encore? It is a public-private partnership. It is an industry-led initiative where we have industry leaders, Ericsson, Sienna, CGI, Thales, IBM, get together with the local governments and put together this program where over the course of 5 years, we had 400 million Canadian dollars invested into this program. And really, the essence of Encore is to make 5G available in its early phases to the research and innovation communities in Canada, all in an effort to stimulate the economy, innovation, and local talent development there. So at the heart of Encore, at the heart of this program, is the innovation platform. So we have 5 incubation hubs at select Canadian cities, and these hubs are interconnected. And they all offer a fully functional, cutting-edge 5G test environment. So leveraging this testbed, this 5G testbed, we're able to really develop the ecosystem around it. So we have our industry leaders, our academics, our innovators, our researchers, but I really wanted to focus in on one particular group of the ecosystem. And that's the small and medium-sized enterprises. So we had 800 small and medium-sized enterprises take part in this program, and they really represented a wide range of industry verticals, whether it was agriculture, healthcare, manufacturing, you name it, it was part of this program. So of course, this really allowed for some great collaborations and some great synergies to take place, and we're going to highlight one this morning for you. So this is an immersive technologies collaboration. Basically, it's a metaverse use case. And it's one of our earlier success stories from Encore, where we had a simulation experience with eliminating the need to be tethered, eliminating the need for some form of local, high-performing, expensive equipment. And this was all through the use of 5G and edge computing. So this is a good example because you really get to see the ecosystem at work. So we had NVIDIA provide their Cloud XR platform and the GPU power. We had Ericsson, of course, with the 5G connectivity. OVA, a Quebec startup, they provided their simulation platform called StarlingX. And at Sienna, we contributed with the end-to-end networking capabilities. And we also supported the edge compute offering as part of this network. So the edge compute in the Encore network is running on OpenStack Cloud. So OpenStack clearly an enabler here for this platform and this ecosystem. And that's where VexHost comes into the picture, right? So VexHost deployed the OpenStack Cloud. They continue to monitor and maintain it. And in a couple of seconds here, Mohammed's going to take us through the how and the why OpenStack is an enabler. But before handing over to him, just going to take a quick moment to thank you for your time, and thank you to the foundation for having me. It's been such a pleasure to be here. And I'm looking forward to see the community in Canada next year at Vancouver. So I hope to see you there. Mohammed, over to you, my friend.
Thank you.
Yep.
So why OpenStack? So when we started working with the team, with George and Sienna, OpenStack made a lot of sense for this sort of project. And one of the first most important things is, if you've been kind of a veteran of these events or you've been around OpenStack, you know that telcos use OpenStack heavily. And so these small and medium-sized businesses, these startups are trying to come in and they're trying to, build R&D and build prototypes for software that, they'd like to eventually make a product. And obviously, when you're building it on top of OpenStack, you are kind of building it for a platform that is already in place for across many telcos. So I'm sure you've seen over these summits and other summits that there's many telcos all over the world that are actually running OpenStack. And so therefore, you can run these solutions on these clouds and not have to kind of port it from one platform to another. You're using the same native platform. Another thing that we've spoken year over year about is the hardware benefits inside OpenStack. So OpenStack, because of its large footprint, it's managed to have a lot of hardware acceleration features. So for example, when we started working with Sienna, we started with PCI pass-through by simply passing GPUs straight into VMs. As time goes by and as we started cooperating even more, we worked with NVIDIA and we started adding vGPUs, which helped a lot in actually maximizing the resources because we went from a 1 GPU per machine that can only serve one customer or one small business to several small businesses that can all share that same GPU. So allowing Sienna and the Encore platform to take more advantage of the hardware without really an extra or additional investment of adding more GPUs. High performance networking, so going back to the thing that we talked about telcos, the presence of telcos has helped enable a lot of high performance networking into OpenStack. So things like SRIOV, DPDK, and other things that allow you to do high performance networking are all a big reason why this makes it a good platform to build these sort of prototypes. Next up, the self-serve capabilities of OpenStack are also great. Obviously, when you're kind of innovating, sometimes you just get an idea and you just want to prototype it really quickly. Having that self-serve and just being able to go in and just build whatever you need to build as quickly as possible, rather than going through requests and paperwork and all of that, that really helps these companies become more agile and get them to kind of produce more and interesting results on their own without having to feel like they're limited by some paperwork or things like that. And then finally, OpenStack, with time, there's been a lot of contributions to the several different projects in order to make it a much better edge cloud platform. And so there's been changes and improvements that have happened over projects. For example, things like now images being pre-cached inside compute nodes, things like Ceph clusters running remotely and images being downloaded from those Ceph clusters. Those are all features that come in really handy for this sort of deployment, considering that the distance from one end to another is around 1,000 kilometers. And these are all compute nodes that are far away between each other across different cities. So we need to make use of these features in order to kind of allow for building this. And the really cool part is we built all of this with open source. So our kind of open source deployment tool that we have called Atmosphere, pretty much what it does, it's an Ansible collection. You can use it for however in-depth you want. So if you want to use roles independently and kind of architect everything yourself, or if you just want to use playbooks that do everything for you, and that's all built using that. So the entire platform is managed by deploying a Ceph cluster, deploying Kubernetes, integrating all those together, and then putting OpenStack on top of it. We have several customers that are also using it, and it's all open source. It includes day 2 operations, things like monitoring, Prometheus, alerting, all of that stuff is all comes, it's fully included. And you know, if you have any questions about it, you're more than welcome to drop by our booth and ask any questions. But that's kind of covering it. I'm going to say thank you, everyone, for joining us. And I'm really excited to see you once again, as another Canadian, to see you guys again in Vancouver. Yeah. Thank you very much, everyone.
Thank you.
All right, thank you. That was another really interesting use case. We have already started talking with Mohammed and George about some demos and things for Vancouver. So yes, I am already teasing the next set of keynotes. You got to come to Canada next year and see them. They were talking about 5G. This is an area where we have seen a lot of activity within our community for years now. And in fact, through the surveys that we run and the data that we collect from users around the world, we have determined that 9 out of 10 telcos worldwide are running OpenStack in their network, which is pretty amazing, makes up for billions of devices. Yesterday, Mark was talking about how we need to get to 50 billion devices. You know, all of you and the software that you write is helping us get there. We have some more to go, but already a lot of usage on that front. One of those telcos is enabled by the StarlingX project and supported by our headline sponsor, Wind River. And next, we are going to hear from Wind River and from their CTO, Paul Miller.
Thanks, Jonathan. The edge is exciting. I think we're here today to talk about the StarlingX project and what has really driven it into existence. Edge compute, distributed computing, is what it's designed to work for. So what's going on with the edge? We've seen, well, we'll see if it moves. There we go. In 2020, about 20% of compute projects had an edge component in them. With Gartner data today, we're seeing that by 2025, about 85% of these projects will now include an edge component. And we're seeing that as part of building technology that solves these problems, we really need the community here and the StarlingX project that's really geared to solve these type of technology challenges to help work towards solving these problems. And we really find that the community is incredibly important towards building the technology. As we move forward, we ask, well, what is the edge and why is this becoming so dominant with what's happening in today's society? We talked, Jonathan mentioned a moment ago about 5G and the build of extremely distributed edge topologies that are running thousands upon tens of thousands of sites, hosting radio application environments, augmented reality and manufacturing environments, telemedicine, autonomous vehicles and vehicle-to-vehicle accident avoidance. This is really pushing compute to the edge of networks. And it's at the edge of networks that now we have software-defined environments that you need a fully virtualized technology that can run that entire distributed system from a single pane of glass as one cloud environment. You know better than anyone, as you've built this technology over the years, that these dreams are extremely complex to execute. The technology that we had built originally in OpenStack 10 years ago, now even 5 years ago, isn't really ideally suited to solve some of the problems that you have in a distributed edge compute system. This is really why StarlingX came to be, to really try to embrace some of these challenges that we have. That means that we recognize that some of the legacy technology approaches aren't ideally suited to solve distributed edge computing. So how do we manipulate the OpenStack and container technologies to solve these problems? As you bring this to an open source context and the Open Infra Foundation, you're often working on individual components within your projects where you're trying to solve particular problems. But we have to recognize that these are complete, complex infrastructures that are used to deploy in production environments. And as part of that, we bring together a lot of open source technologies in the Open Infra Foundation to build a complete infrastructure. StarlingX, like OpenStack, is a complete infrastructure. It can be deployed and run the entire cloud technology from bare metal all the way up to the application within that project's capabilities. And so it's really more of an infrastructure view of how we deliver a production-ready environment for edge compute systems. And so if your future's on the edge, if you're interested in these types of edge applications, as you'll see them coming more and more to the forefront, StarlingX wants you. We want you to join the community and be part of this next generation of distributed computing and cloud technology. My name's Paul Miller. I'm the Chief Technology Officer from Wind River. We're a co-founder of the StarlingX project and an active contributor. We're really excited to have you here to talk about this. We encourage you to stop by. We'd really like to talk to you about this open source project and how it's used to solve a lot of these operational problems of deploying and managing distributed networks. It's beyond just the technology to host an application through hypervisor or container technology. It now includes a huge amount of tools and capabilities to manage, visualize, and operationalize a completely distributed virtualization topology across thousands to tens of thousands of sites as a single virtualized environment. This then really represents StarlingX, the project, the ideal open source community where people can come together to work on this next generation problem and really solve these problems for the businesses and customers that we all have that are looking to deploy these types of advanced solutions. So what is StarlingX comprised of? StarlingX was started as a cloud-native first approach, where we take a lot of OpenStack components to bring the technology together and operationalize it using some of the best attributes of what was done in OpenStack, but then bringing Kubernetes and container runtimes like Docker and Containerd to run containers directly on bare metal for the highest possible performance at the edge of the network. Using other modern components that you see here, Ceph, Calico, Yocto real-time kernels, pulling that together into a complete infrastructure project, not unlike OpenStack, but for distributed computing. It's also a production-proven and hardened solution at this point. As Jonathan mentioned, we have some great activities in our business working with Verizon. If you actually travel to the United States and turn on a Verizon phone with 5G, you're actually running on StarlingX. That's in production deployment today, carrying production traffic, using a technology called virtualized radio access network, where at the edge of the network, all of these components are fully virtualized and running on general purpose compute on top of the StarlingX infrastructure. Vodafone in the UK, using this under the new ORAN initiative, or Open Radio Access Network, another open source project, to deploy radio access networks in a fully disaggregated approach to their network. Elisa in Finland, an incredibly advanced technology-centric company looking to operationalize cloud infrastructure for telecommunications workloads. KDDI and NTT Docomo and others doing virtualized 5G infrastructure. It's also an area where we've had a great community collaboration between open source initiatives. You may have heard of the ORAN Alliance, or OpenRAN. There's also the ORAN software community that works with the OpenRAN to build a completely virtualized approach to building radio access networks for 5G. StarlingX has been contributed as the foundation for ORAN. In all of the different 5G split models, the O-Cloud infrastructure as defined in ORAN is actually StarlingX. And so there's a great partnership there happening between open source communities. So I talked through a few of the use cases early in this presentation, and we're going to dive a little deeper on some of the requirements they come with and why that would create a new project, that being StarlingX. But I want you to recognize as we kind of walk through that recent material why it was driven into existence, what it's trying to solve, and that it's really built for the future and solving active problems in production deployment today. And you could find a tremendous amount of mutual benefit from joining and participating as you look at the type of technology problems this solves. So what's different about the edge? And as you look at the topologies and physical footprints of what you're trying to build for a cloud infrastructure, it used to be that we were trying to build clouds for large data center environments, tens to hundreds to thousands of compute nodes within a single data center facility. at the edge, we still have these scale problems. We have tens of thousands of computers that are being pulled together into an end-to-end virtualization topology. However, it's now geo-distributed. These thousands of sites are separated by tens or hundreds of miles, and at these sites, they may have a single compute node, or a pair, or 10, sprayed out all over a country, but being run as a single cloud infrastructure end-to-end. So it creates a lot of new interesting challenges for building and operationalizing that type of a cloud infrastructure. And that's what StarlingX is geared to solve. If we look at the footprint issue, at the edge of a network where TCO is extremely sensitive because you've got thousands of these sites, getting ourselves down into a single node, a hyper-converged infrastructure option, was a key piece of what StarlingX did with the technology. Shrinking that footprint down to a pair of cores within the compute platform, freeing up the remaining cores for the actual virtual application to run, creates the highest performance, low-cost application for an edge compute node. If we look at scalability, you need to scale at each site to even to hundreds of nodes, but now you need to scale across thousands of sites and operationalize that, build a control plane that's self-healing across that network, and create a single pane of glass to look at that entire distributed system, no matter whether each site is running a Kubernetes environment or an OpenStack environment, into a single managed cloud. You need ultra-low latency. As you approach the edge of the network, we talked, for example, about vehicular applications. A great example is vehicle-to-vehicle accident avoidance. In modern cars now, even before autonomous vehicles, if the system in the vehicle is following a truck and you look to make a turn, right now the cameras and LiDAR can't see around that truck. There's insufficient information. But there are other vehicles in the area that if you had the ability to connect those systems together, that vehicle about to take a left-hand turn could get additional data to make that decision more safely. Now, we're talking about a real-time application which has ultra-low latency. From vehicle to vehicle, you need a 5G low-latency connection between them, and you have a virtualized application sitting at the very edge of the network participating in connecting these data streams so these systems can make intelligent decisions. This is an example where ultra-low latency and high performance and real-time kernels are a critical part of the edge compute system. Security is a new problem. The threat profile of a highly distributed system, that threat surface is huge, right? That attack surface. And so unique security challenges need to be addressed, and StarlingX takes a shot at doing that to ensure that this highly distributed system is also a secure system. Lifecycle management is incredibly important. We all know what it was like over the years as we built upgrade capabilities into OpenStack and how painful that's been to bring to reality. In StarlingX, we started with that as a fundamental requirement. So the ability to perform live upgrade on the system, live patching in the system, and even roll back to previous versions is intrinsically part of StarlingX. So the ability to deploy and manage these systems is incredibly important. And of course, open source. The customers demand open source, and we really see the incredible benefits of having crowdsourced innovation coming into the technology. And that's why we co-founded this within the Open Infra Foundation to really drive community participation. And as we sit here now in 2022, we're really just getting started. In 2020, we became a top-level project within Open Infra and have really got now to the point where we've got in production deployment and actual use of the technology. It's a great time to jump on board and start working on these problems that are just starting to emerge in 2022. So working with the StarlingX project, if you're interested in distributed energy systems with wind and solar, advanced manufacturing environments, 5G infrastructure, distributed edge compute, this is the place to come work. We'd really like to see you join, and I think you'll have a great time on the project. We have a few sessions here yesterday and today that we'd like to invite you to. There's a one-on-one session to learn on how to get started with the technology. There's a strategy session to see how it's being used for edge use cases. There's a session about how to deploy and upgrade and manage these sites, which is a pretty significant operational challenge. And there's lightning talks as well as a StarlingX lounge that you can come hang out at. And we certainly encourage you to come visit Wind River at our booth. We're glad to talk to you about everything we're doing here in the open source community as well as with the technology. Well, so thank you all very much, and hope you find that very interesting. Jonathan?
Thank you, Paul. I had the opportunity to have dinner with Paul last night, and we talked about some pretty amazing use cases that StarlingX is in that I hope that we'll be able to share and do case studies around over the coming months. It's doing a lot of lot of very cool things. As he mentioned, there is one of our lounges where you can go rest and charge your devices and hang out if you need a break from the session rooms downstairs, so please go check that out. We're going to move from telco and 5G and the edge to another topic that has been super active and really, I think, at the top of a lot of people's minds in our community over the last year, which is around hardware. So we have a couple of sessions talking about what's happening in hardware overall and also in the open source community. And to start that off, please welcome from Fungible, Toby Owen.
Good morning. I'm here to talk to you a little bit about DPUs and how they can enable composable infrastructure. First, let's make the case for why we need a DPU, and then we'll talk about what it is and a little bit about what they can deliver. So Mark stole my slide yesterday. So we all know that data is growing, and in 3 years, we're expecting about 181 zettabytes. So I thought I'd add to the story a little bit and explain through an analogy what a zettabyte is. So if you took a potato, and let's say a potato is 1 byte of data, and then you stacked a zettabyte of potatoes, it reaches 16,000 light years. Another way to think about that is 2,000 round trips to our nearest star system, Alpha Centauri. And that's just 1 zettabyte. I've got some favorite slides here, or favorite statistics, rather, about data growth. You know, in a day, we're seeing 1,000 petabytes generated every day. That's 2.5 quintillion bytes of data. If you wanted to download the internet yourself, you better get started. It's going to take you about 181 million years. My European friends especially really love WhatsApp, and that platform generates 65 billion messages a day. Of course, not to be outbid by anyone. Twitter is neck and neck with WhatsApp in terms of message volume. And what are you contributing? Every individual is contributing about 1.5 megabytes every second. So if you thought no one was looking while you're checking your social media feeds while I'm up here talking, think again. That data is being collected. Probably one of my favorite statistics here is YouTube. We see about 750,000 hours of new content uploaded every single day. I think my teenager son watches about half of it. So on top of all of this social data, actually the number one driver for increased data is Internet of Things. So a few observations from all of this. Obviously the data stats are fun, but I think with the rise of data and the volume of data being created, it's just becoming too expensive to move all this data into centralized data centers. The last speaker spoke about this as well, right? The need for edge. And so in order to do something with this data, the computation has to move to the data rather than the other way around, which is how we've always done it. The second observation would be this data isn't just getting dumped in a database somewhere to be looked at later, right? It's requiring more and more real-time analysis. You know, what's the value of sensor data when you're in a driverless or an autonomous car going 100 kilometers an hour if it takes 30 seconds for a response to come back to say you're about to crash, right? It doesn't really help. We're also seeing some long-term trends that we've come to know and love start to change. Moore's Law here. We've been expecting CPUs to double every 18 months. Some people say it's now every 3 years. We're also moving everything towards software-defined. But if the rate of growth of performance of CPUs is slowing, but the volume of data and the need for real-time analysis is growing, we're going to hit a limit where CPUs, general-purpose CPUs, can't provide all of what's needed anymore. Right. Another trend, the rapid rise of containers. I'm preaching to the choir here, obviously, but you see virtual machines that we all know and love continuing to grow, but containers are on pace to reach, in terms of installed instances, in the next probably 3 to 5 years, the same volume. And containers are really about time to market. It's about agility, right? The speed to write an application, to deploy it, to manage it. But the reality is infrastructure, the underlying infrastructure, hasn't really kept up in terms of speed of deployment, in terms of flexibility. So what's the answer? I'll share my view, which I think is composable infrastructure. And that really starts with the story around a data processing unit. What is a DPU? It's a purpose-built microprocessor that's specifically targeting data path acceleration. At Fungible, we saw a big gap in the market around accelerators targeting data-centric tasks, and so we built one. Actually, we built two. And so by accelerating these tasks that are used in data management in silicon, and then putting those DPUs close to the data, we can accelerate these tasks, sometimes 10 times or more. We also built this chip to be flexible, to allow us to program specific data paths, for example, storage. Software-defined storage typically runs on a standard x86 processor. We've seen hard drives, now SSDs, continue to increase in speed and throughput. Networks are also growing. And so there's really kind of a limit that we're seeing around general purpose processors. A specialized processor, like a DPU, has specialized accelerators in the silicon to do all of the data management tasks, things like compression, encryption, even erasure coding. And this allows these processes, the storage-specific processes, to happen as data flows through the DPU at wire speed. And it really allows the flexibility and performance that software-defined systems really can't accommodate with a general-purpose chip. I think the bigger value, though, in a DPU is the enablement of what we call composable infrastructure. And this is kind of a new marketing term, or a new market, really, that's evolving. But the DPU by itself, as an enabler, sometimes can be difficult to consume. And so we've built systems, infrastructure systems, to make these capabilities of the DPU easier to consume. We've got PCIe cards to do offloads. We've got a scale-out storage system with a Cinder driver. And also, most recently, we launched a composable GPU system to allow GPUs to be pooled and mounted remotely on servers over Ethernet. In fact, all of our solutions are designed to run on standard high-speed Ethernet. All right, so what's a DPU capable of? Let's share some statistics or some data. First is a DPU-powered storage cluster that's using NVMe over TCP. We've been involved in actually 2 world records being set in the last year. The first one was with NICAV, a research institution here in Europe, and they clocked 6.5 million IOPS from a single server to a single storage target. Not to be outdone, San Diego supercomputer ran the same test, essentially, same initiating server, again against a single storage node from Fungible, but they came in at 10 million IOPS. Both were using a DPU-powered storage node, and both of the initiating servers were the same. So what was the difference in performance? Well, in San Diego supercomputers test, they installed DPUs also in the initiator to function as a hardware-accelerated storage initiator. That allowed the offload of almost 75% of the load of the CPU, and almost doubled the result, the performance result. What that means is 96 cores on that box, and this is not a standard server. This was a big server, but 96 cores given back to the application. In other words, the server can now do what it was designed to do, while the storage can be handled by the DPU. Another example, GPU composition over the network. Just 2 months ago in April, we launched a system called the Fungible GPU Connect, which allows remote connection of GPUs over Ethernet. Here's some of our test results. We ran a couple of standard machine learning benchmarks, and we were testing a direct attached GPU to our solution using PCIe over Ethernet. In this example, a single A10 GPU, and you see across a variety of batch sizes in ResNet, the performance is basically on par, right? In another test, we used 2 A10 GPUs and a different algorithm to test. And again, the results are really within the margin of error of the test. So the GPUs can really do some things that we just couldn't do before. And my last example here, let's look at a feature in development, which we're calling computational storage. And this is not a notion that we invented, certainly, and there's an emerging body of standards trying to define how to do computational storage. There's a couple of approaches in the market today. One is to move compute down into the drive or the SSD, maybe move it onto the NVMe bus. Because we have DPUs in our storage node, we're using that approach to run computation directly in the storage array. So let's take an example of a SQL database, and let's say we've got 1 billion records, and we want to query that billion records for, let's say, the 1,000 fastest particles. Let's say this is a particle research lab. In a traditional architecture, the database server is going to fetch the data in chunks. It's going to run the filter. It's going to pull that back to the database, run the filter, and repeat that. That can result in hundreds or thousands of round trips on the network. If you can push that query down to the storage itself, run that filter operation, that query in the storage itself, you end up with a single round trip. So what does this look like in practice? Well, in our labs, we saw with a single thread on our DPU, a 75x improvement in query execution time versus a MySQL database running locally. Another example is regular expression matching. Compared with a software implementation, running the expression matching on a DPU, we saw over a 25-time improvement in the throughput that was capable. And now again, this is a single thread. Our DPUs and everyone else's DPUs have multiple cores. We've got multiple DPUs across the network, and so the potential here is really pretty impressive. So in conclusion, data and the apps that need that data are getting more demanding. Infrastructure really needs to respond. I believe DPUs will become a regular part of the modern day data center infrastructure, and systems that leverage DPUs are really key to building the composable data center, which is going to allow us to bring the same agility that we all know and love from the cloud down into the infrastructure itself. This was just really a teaser. So thanks for your time, but we do have a session actually right back here in this room tomorrow. If you'd like to hear more, we've got a little bit more time to dive a little deeper. So I appreciate your time, and enjoy the rest of the conference. We look forward to talking with you. Thank you.
All right. Thank you, Toby. So I guess maybe we're also building an internet of potatoes or something along the way here. Continuing on the topic of hardware, next up we're going to talk about how to manage the hardware you have, how to share it, maintain it, and do that all in a secure way. So we've got a big crew coming out for this one. Please help me welcome Jon, Trammell, Orran, and Julia.
Thank you. Good morning. I'm Jon Stumpf. I'm head of infrastructure engineering at 2 Sigma Investments. I, along with my colleagues here, are here to introduce our work to make an elastic, secure data center. The security experts wanted this name, but we wanted the snappier title. So while there are 4 of us on stage, this work is part of a much larger community of researchers and developers that have been working on this project since 2014. The engineers in red are currently developing solutions today. Now, my team runs the physical IT infrastructure at 2 Sigma. We have a large infrastructure supporting multiple entities with different security profiles. And data confidentiality is of utmost importance. The things I worry about are a drive or a server leaving the premises without being wiped, or a server getting compromised. Back in 2014, we began a research project that would satisfy 5 objectives. Ensure the machine is in a known, safe state prior to using it. Prevent the loss of confidentiality by encrypting the entire disk. Separate the encrypted data from its keys, enable the computers to be repurposed in minutes, and have a solution that is auditable, scalable, and ubiquitous, applying to all manufacturers, all clouds. It's a fully loaded potato, but I think we can make it. Come on. What I really want is a fundamental platform that defines a contract between a provider and its tenants. As a provider, I want to deploy this to my data centers, and as a tenant, I want to use this cloud. I want to use clouds that employ the same platform. Now, the tenant should be able to do what they need for their own security. I don't want to trust my cloud providers, and I don't want my tenants to have to trust me. Trust should not be necessary. We are proving these concepts and methods in collaboration with the MOC Alliance, which Orran is going to discuss about. Next.
Thanks, John. So the MOC Alliance is a project to create an open production cloud for a group of large institutions in the US. These institutions own and operate large data center, MGH PCC, 15 megawatts. And the research John talked about is resulting in a new fundamental platform for this data center. We're currently deploying it and working to deploy it on about 40 racks. And the goal is to get it out to the whole data center. To give you a sort of feeling for the scale of it, you see sort of the layout of the data center, and this is one row in that data center. So it's a kind of massive scale. To understand the challenge we're dealing with, we have thousands of researchers, or tens of thousands of researchers studying everything from potatoes to quantum computing. There's the Northeast Tier 2 Atlas site. There's the Open Cloud Testbed, which is a new national testbed in the US for cloud computing research, available to researchers from across the US as well as the open source community. We hope to support hundreds of thousands of students doing their coursework. Security sensitive things like researchers doing research for the intelligence agencies, hospital researchers with HIPAA compliant data. And alongside this, we actually want to support the cybersecurity classes from some of the top universities, on that same infrastructure. So at the basic level, to avoid side channel attacks, we actually want to give physical servers to everybody, and to also support bare metal services like the Open Cloud Testbed. And we have a big problem with this. The problem is that our demand is highly variable. This is the first year of the Open Cloud Testbed, where on the vertical axis you see machines, and on the horizontal axis you see time. And it's incredibly variable. Why is it so variable? Well, this is the deadline for one of the major operating system conferences, right? The day before, it's of course 100% utilized the next day. This is the problem when you actually have infrastructure, physical computers that are dedicated to clusters, where everybody using it has the same publication deadlines. So what we want is to be able to move computers between the different clusters, and we actually want to do this rapidly. Why rapidly? Well, as Stig was talking about before, we had to repurpose a whole bunch of our infrastructure to deal with COVID rapidly, or the Boston Marathon bombing. So we want to be able to do this very quickly. And security is actually essential. We're moving computers between graduate students that are deploying their own bare metal operating systems into HIPAA-compliant enclaves for production use. So now Trammell's going to talk about how we do this rapidly, and more importantly, how we do this securely.
So as Orran mentioned, transition between tenants takes too long due to the need to clean up all of the persistent state in the systems. And some of this is runtime state that is cleared out by rebooting the machines. And this reestablishes the static root of trust. This also refreshes the UEFI and SMM runtimes. But these reboots take several minutes on real hardware. And more security-conscious tenants might want to do a multi-pass disk wipe that could take several hours. And that's even better than the way John decommissions disks right now. This sort of one-way secure erase is really problematic when we want to move resources elastically between different tenants. Then there are also the firmwares, and that's firmwares plural because pretty much every component in a modern server has some sort of programmable code in it. And some bare metal providers have not been checking these for alterations by prior tenants. And part of the reason is that flashing firmwares takes a while. So to try to make this sort of handover more efficient, we're trying to enable a radically different approach that recognizes that different tenants have different threat models. Orran students submitting to an academic conference have a very different security concerns from a financial institution. Teams like Jon don't want to have to trust the provider, so they need to be able to verify the firmware on the devices themselves. So to support these different sort of threat models, our approach has been to create a minimal, untrusted provider platform that allows each tenant to control their own security. We've also built an open source toolbox of security mechanisms that each tenant can combine to produce policies that meet their specific threat models. And since these tools don't depend on the cloud provider, they reduce the trust the tenants need to place in the provider. And it's also better for the provider since they don't have to meet the most extreme requirements for every single tenant. Although we are trying to support very security conscious tenants in an efficient manner. So rather than scrubbing the local disks, for instance, we're enabling disaggregated encrypted storage with remote attestation of the state of the system. So when booting, the system sends a quote of its state signed by its trusted platform module to a tenant-controlled remote attestation server, which can then evaluate the state of the booting system. And if the system is in a trusted state, the attestation server can reply with encrypted secrets that can only be unsealed by that specific TPM on that specific boot to decrypt the disks. And this attestation process of validating the quote and event log is orders of magnitude faster than reflashing the x86. The TPM signed quote also detects certain classes of attacks on the firmware, configuration, or boot process by the cloud provider or by prior tenants. So this remote attestation gives us a faster, safer boot path, while also allows us to flag suspect systems for more in-depth remediation. And reestablishing trust in a compromised system might require hands-on in-system programming of the system firmware to be absolutely certain that everything has been reflashed. For the non-x86 devices in the system, however, there are a lot of open problems, such as compromised peripheral devices or hardware implants. These are currently out of scope, but we're actively researching these sorts of physical attacks and trying to better design our systems to be resilient against them. So Julia is now going to talk more about the software components and how they help us to secure the cloud platform.
In order to build a provider platform, you need to be able to manage an inventory of bare metal. You also need to be able to facilitate actions upon that bare metal, such as power on and power off. This community has built this in the form of Ironic. We also need to be able to provide networking, allocate, and attach those networks. And this community has also already built this in the form of OpenStack Neutron. And the reality is that this community has built 99% of the foundation that is needed for this work. With the security toolkit, a tenant is empowered to make their own decisions. For example, a security-sensitive tenant could allocate one or more computers, place the untrusted computer on an isolated network, provision the computer using whatever tools the tenant is comfortable with, and then use attestation to measure the machine's firmware state and ensure it has not been compromised by the previous tenant. And only if successful can that machine be attached to the normal network, and all network and disk storage can be encrypted. Our goal is to remove the necessity of implicit trust, because realistically, it is required in many cases today. We also want to empower the tenant, because the tenant is our user. And we want to provide the fundamental security for open infrastructure, because as Jon said, he doesn't want trust to be necessary. We're going to discuss our current solutions and the open problems in the breakout sessions tomorrow. Join us and get involved.
Thank you. Thank you.
As Julia said, that there's a session tomorrow for that, and also all of the things that they're working on are being done in the open, as our community is accustomed to. So that's a really cool set of hardware enablement that I think is important work. We have one more session, and this one is going to cover not just hardware, but hardware in motion as we talk about autonomous driving with Zuul and Volvo. So please help me welcome Jim Blair and Johannes Foufas.
We're going to talk about the Zuul development at Volvo Cars last year. And this is a summary of our CI infrastructure stack. Down in the left corner, you can see that we use Zuul and Ansible, and mostly we use Gerrit. And last year, we had a massive growth rate of Zuul. We connected up to 600 Gerrit projects, where we started for around 200. And this has been a massive growth that also caused us a lot of issues to handle and solve. Last year, or 2021, we also won the Volvo Cars Technology Award. And this is really great because this made us seen by the whole company. And we were voted to this prize, so it wasn't a jury. It was actual developers who voted for us. And for us, a game changer is James Blair and Acme Gating helping us.
Hi. 10 years ago, I started the Zuul project to help make sure that every change to all of the OpenStack projects were tested together before they're merged. And a year and a half ago, I started Acme Gating to help bring Zuul into the enterprise. Volvo runs Acme Enterprise Zuul, which is a fully supported distribution of Zuul that is responsive to enterprise needs. It's sometimes it runs a little bit ahead of upstream, sometimes it runs a little bit behind, but it's always open source. Everything that we do in Acme Zuul goes upstream. And in fact, this is really core of how we do development in the Open Infra community. Whenever we're working on a new feature or something for enterprise customers, all of that development happens upstream. And so this lets companies like Volvo and others get the support and the help that they need, the features that they need in Zuul for their enterprise, and the entire community participates and benefits from it, and everything stays open source.
Yeah, and as you can see on this slide, we have some really important features that helped us develop, especially, I would say, optimized performance that really helped us because we had this huge growth in projects. I mean, basically, we just poured in projects and we became the default CI chain at Volvo Cars for the code that is in the actual car. And it's also the code that will make autonomous drive possible. So this is great. And here you can see some of our team members, and you can see James there. He drives for us, in a way. Yeah, so one of the really important features we use with Zuul is the gating and the gating of dependencies, because a modern car ecosystem had a lot of dependencies, a lot of nodes. And with Zuul, we can actually take these dependencies and gate them. And this is extremely important for us, to be able to speed up our development and have code that works all the time. So our current Zuul setup, before I went, I checked the image name, and that's the name. We run 6 schedulers, 10 executors, and 6 pods for the web. And the backend is run in an EKS Kubernetes cluster. So our biggest Zuul challenges. Yeah, some of the onboarding teams said, oh, Zuul is slow. Well, it's not anymore, at least, and that's thanks to James. Because of the massive amount of projects we added, the system got a bit slow. So you see a graph here. This is the time it takes from a Gerrit event until the first job starts in a pipeline. And I just took a snapshot from a day of work, and you can see here it's around, I think, yeah, a minute, 1.5. So I think that's quite decent for a system as large as this one. And other things we got from James then is detailed metrics that's upstream. so we can, or I and my team can see exactly what's happening and why. I mean, if the times run away, why do they do that? And we also made better use of tenants, and we also had global semaphores that James helped us develop, because we use a lot of proprietary licenses. We don't want to put all the projects in one tenant, because then Zuul becomes slow. So Jim just developed a tenant-wide semaphore. And also, one very big thing is the optimized reconfigurations, because we just add so many teams, we add so many projects, and that slows Zuul down, because it has to parse the YAML files and the pipelines. So that was optimized. So our future of Zuul is scalability. So we want to use Kubernetes clusters for worker nodes also, not just for the backend. And I think a week ago, one of the team members just showed us, like, here you are. So we're now running at least simple jobs. And we also want to be able to switch between AVS and Azure as a switchable backend. So today it's AVS, but we want to not want to be dependent on that, so we want to be able to switch with like a Boolean, back and forth. And we also have a request internally to run Zuul jobs on an OpenShift high-performance computing cluster. And that, I think, is really exciting. So we're just looking at the drivers.
There's a number of Zuul sessions coming up today. Clark is going to be giving a talk about advanced features of Zuul as used by OpenDev. So you'll see a lot of really interesting things of what Zuul can do by people who are really pushing the boundary in developing Zuul itself. After that, I'm going to be giving a talk called Project Gating with Zuul. So if you'd like more of an introduction to what Zuul is and the project gating philosophy, I'll try to help you out there. Then there's a series of talks by a number of companies using Zuul, and these companies are no small potatoes. BMW is going to be giving a talk called No Gain Without Pain, a story of how they scaled their CI with Zuul. Workday is going to be talking about how they're building their next generation private cloud. And then finally, Johannes here will be diving in more deeply about how Volvo is using Zuul.
Thank you very much.
All right, so thank you to all of our speakers, and I want to give one last thank you to our crew. As many of you know who've come to our summits before, we've worked for a decade now with an event partner called F&Tech. They followed us all over the world and helped make these events possible. So if you see an F&Techer out and about in the venue, be sure to give them a fist bump too. And also the whole crew who worked on the keynote. We ran 30+ speakers through this stage in the last 2 days. Can't do that without an awesome crew. So I want to give them a thank you and a round of applause too. They all become part of the community as well.
They are part of the community. Well, keynotes are over, so head out to the sessions, and don't forget to have a great or good time with Open Infra. I like great better. I can't change the tagline.
Can't change the tagline.